G'day everyone. Today what we're going to be looking at is we're going to be looking at 3D lines, okay? So lines in 3D. Now this can get a little, not, I guess it's not complicated, but you just need to keep your head a little bit to sort of make sure you understand what's going on. So the maths is pretty easy, pretty straightforward. It's just the concepts that you need to sort of take care of. So just before I start, I just want to sort of go back to two-dimensional lines, okay? So, let's say we have an equation y equals 2x plus 3. So two-dimensional line. And so what's happening here is that you start with a point, and this point is 3. In this case, it's the y-intercept, and it's 3. And then there's some instructions given from there about where the line goes. And in this case, the 2 in front of the x, and so that's our gradient. Okay, so m is equal to 2. And we know that that's 2 over 1, which is like, rise over run. And that's sort of the instruction to how to create the line. So you start from the point 3, and then from there, you go up 2 and across 1, and you get to this sort of new point. And then, and then you go again. After that, you go up 2 and across 1, and you get this new point. Up 2 and across 1, and get this new point. And the line that we end up having is just sort of goes through that. And that sort of defines the point. So just to summarize, what you have is you have a starting point, 3, and then that number in front of the x gives you some instructions about which direction does it go in. And lines in 3D are actually exactly the same. You're going to start with a point. You're going to have some sort of point P naught, where, it might be three-dimensional now. Well, it is three-dimensional. And you can see how with the 2D line, it's two-dimensional because it gives you the rise and run. But you might have some point, 3, 2, 4, whatever, doesn't matter. You're going to start at that point, and then you're going to have some vector that shoots it off in a particular direction. I'm just making up stuff here. It doesn't matter. Okay, so you're going to have some point in space. So you're going to have this P naught. And from that P naught, it's going to shoot off in a particular direction. And this V, that directional vector, tells you the direction it's going to go in. So hopefully that makes a little bit of sense. It's going to take a little bit to get used to if this is the first time you've heard of this concept. And what we're going to use, whereas in the previous example, it's the gradient. So you can think of the gradient as being a bit similar to the direction vector. And instead of having y equals x, you'll see what the difference is between this next section. We're also going to introduce the parametric t as what's going to be happening here. So essentially, what happens is you start at the point 3, 2, 4, and then what we're going to do is add slowly. We're going to add to that t lots, so t lots of this vector v. And so we might have one lot of vector v that we're adding to this, and then 2 lots of vector v adding to that, and then 3 lots of vector v. And so what's going to happen, slowly is we're going to build up this set of points that defines a line. That won't make a whole lot of sense now, but when I sort of start doing examples, hopefully you'll see that what we're doing is we're starting at a point and shooting off in the direction of the vector. And each time t increases, that vector gets further and further away from where it started in whatever direction is defined by this vector v. I hope that makes sense. And so let's actually have a look at what that actually looks like. So what is the equation of a line? Okay, so equation of a 3D line. Okay, so if that line passes through a point, I'm going to abbreviate things. And let's go again, that point. Let's call it x naught, y naught, z naught. So if it passes through a point in the direction of some vector v, and let's define that vector as ai, bj, ck. So in that direction, so that's the way it's getting shot off. Then we're going to have sort of 3 ways to represent this line, and you need to be fluent with each of these. So I'll just change color for each one. So firstly, we're going to have a vector equation. Okay, so the vector equation here is RT. We use these for parametric equations, parametric vector equations. What that's going to be equal to is r0, so our starting position vector, plus t lots of v, like I just sort of explained before. So however many, as t gets bigger and bigger, then that vector sort of shoots the value off in that way. So that one is called the vector equation. And just for sort of reference here, r0, what that essentially is just the position vector of p0. Okay, so that'll make sense once you start seeing examples. So we call that the vector equation. We can also write the line in parametric form. So the parametric equation, what that would look like is you'll see it again. It'll be much more clear when I start doing it. But what that is x is equal to x naught. So at its initial x starting point, that there, starting there, and then plus t lots of a. So it's starting at that point. The x values are starting at that point, and for every t, it increases by the a, whatever the number is in front of I. Okay, so that's how x is increasing. And y and z increase in a similar fashion. So that's just y0 plus t lots of b. And z is equal to z0 plus t lots of c. And so that's what it looks like in a parametric form. Again, once I start doing an example, you'll be much happier. It'll make a lot more sense. And thirdly, you can write this in Cartesian form. So just remember that Cartesian form is when we don't have any parametric parameters, no t's or gammas or anything like that, purely just in terms of x, y, and z. And so in Cartesian form, and this is just rearranging all this junk up here, we can rearrange that for x and evaluate t. And again, you'll see that in an example in a second, is that x minus x naught over a is equal to y minus y naught over b, z minus z naught over c. And so you'll see those Cartesian forms. You'll see what this looks like in a second. I think the best way to learn this particular topic is by doing examples and sort of understanding what's going on, because this looks pretty random how it's set out at the moment. So best just to dive in. I'm just going to do one example in this video and then sort of go in more depth into the next video. Okay, so let's just have a look at a quick example. And we'll do this one here. So given an equation t is equal to x minus 4 over -1. Alright, it's getting pretty messy there. Y plus 4 over 2 and z minus 5 over -3. So given our equation of the line there, so that defines a line, and you'll see that that is in Cartesian form, at least the second, that this part of it. Why did that not work? Because it's on the second page. I don't know why that didn't work. That part there is the Cartesian form, and so I'll have a look at that in a second. But it's also got the parametric t out the front just to define it. So given that, can I write on the next page? I can. I don't know why that didn't work before. Given that, determine if the point 1 to -4 is on the line. So we'll have a think about this. So given this particular equation here, is the point 1, 2, 4 on the line? So basically, it's a bit of a substitution exercise where we want to have a look at to see whether this x value, this y value, and this z value all appear on the line for the same value of t. So as if you get the same value of t, so at the same time, all of those things are going to be true for this particular equation. And so there's a couple of ways you could go about it. You could substitute in x equals 1, y equals 2, and z equals 4 into all this up here. And hopefully you get the same t value. And that's kind of what we're going to do. But I just want to sort of do it a slightly different way just to show you sort of what's going on. Okay, so I'll leave that there and I'll do it in blue. Okay, so given that t is equal to x minus 4 over -1, I just want to show you how this works. I've just sort of taken this first chunk of our definition there, and I'm going to rearrange here. So if I rearrange that for x, what I get is that x is equal to, I times both times by -1, so negative t, and then move that -4 over to the other side, and I get x equals negative t plus 4, right? And I just want to see for what value of t is this true, which for our first point here, okay? And so therefore, if I sub in 1 into here, so my value of x there, if I sub in that, I get 1 equals negative t plus 4, which leads me to t is equal to, that'll be 3. Okay, so moving that across there, you get t is equal to 3. So that means sort of like you think of t mostly as time. So after, let's say, 3 seconds, going along this line, the x value will be 1. So what we now need to do is to go back and find what values of t will the y value be t2 and the z value be -4, and hopefully they all occur at the same time. So let's have a look at the y section here, okay? Let's have a look at this now. So t is equal to y plus 4 over 2. And again, if I rearrange, I get y equals 2t minus 4. For my y value of 2, I'm going to sub in 2 is equal to 2t minus 4. And if I solve this for t, bring the -4 over to this side, so that becomes 6 divided by 2. I get t is equal to 3. That's good. That marries up with that here. So far, when t is equal to 3, I've got my y value up there, and I've got my x value there. So what I'm hoping for, well, not really hoping for anything, because I just have to determine whether that point is on the line. If it's not true, it won't be on the line. If it is true, it is on the line. So t is equal to z minus 5 over -3. This is the third section here. The z value is there. And what we're going to do is we're going to sub in our value of z here, so -4. Oh, sorry, I just want to rearrange first. My apologies. Z equals -3t plus 5. Okay, and then I'm going to sub in, go up just a little bit. I'm going to sub in, what am I subbing in? -4 for z. -4 is equal to -3t plus 5. If I solve that for t, I move the +5 to the other side, that'll be -5, so that'll be -9 on the left. -9 divided by -3 is 3. And so I get t is equal to 3. And so what that means is that this point is on the line, because for the same t value, you get the equation giving you the point 1 to -4. And you can go back to it if you want to. You could go back to the original equation and sub in t is equal to 3 for all these values here, and you'll see that you'll get x is equal to 1, y is equal to 2, and z is equal to -4. So we'll leave the video there for today, and then next video I'll start going through some actually how do you find the equation of a line type things. So I'll see you in that video.